Welcome, everybody. Thank you for joining my talk. Thank you for welcoming me back to Hack.lu. This is my second time. You guys are an extremely friendly audience, and because I'm only here for the second time, I wouldn't have witnessed any other times where that would not have been the case. It's incredible to be back. Thank you. So I'm going to be talking about integrating Zeek with third-party applications. So this is not going to be a total deep dive into Zeek to explain what it does. It makes some assumptions about, your existing knowledge of the systems, but in principle, you really just have to know that it's a network monitor, and that gives you good logs about the activity going on in your network. So hi, I'm Christian. Again, I am the tech lead in the Zeek project. So there is I don't know how much you know about the setup of the project, but there's a leadership team, and it basically has one tech lead seat, and that is my current role in the project. I'm a recovering academic. I used to write papers, so I'm really enjoying all the presentations here that have this sort of, researchy vibe. It's really cool. It's, I think, the most fun stuff to present. Very cool. And I work full-time at Corelight. Maybe you've seen our booth out there. What I'm talking about today has pretty much nothing to do with Corelight other than that they pay me to work full-time on Zeek. So this is not a product-y presentation at all. Okay, so let me start by explaining how communication in a Zeek cluster works. This is, I think, sort of useful backdrop to have for this presentation. So if you were here last year, then you might remember this diagram, but it's sort of a very high-level view of what's going on in Zeek. And I probably don't have time to explain every single box, but just sort of the high-level bit that you should take away is that you basically start at the bottom with ways to shove the packets into the system that then get parsed. Sort of a unique property of Zeek is that it turns sort of the parsing activity into events. What an event is essentially depends on sort of the part of the packet that you're looking at. So for, DNS, an event might be a transaction request or a transaction response. For TCP, it might be something like a connection gets established and so forth. So basically, events get generated in the system as the parsing sort of progresses through the packet. And then these generated events get shoved into an event engine. When the parsing is complete, that event engine gets drained, and basically these queued events are processed in a script interpreter that sits on top of the whole thing, where Zeek features its own language or JavaScript that you can do something with these events. And the typical activity that we use is to basically turn these events into logs. So at the very highest level, if you've never heard of Zeek before, basically just consider it sort of a transcription engine where, it tells you at a pretty high level, but more detailed than NetFlow, say, what's going on in your network. Okay, so, and this is what a single Zeek process does. And now in practice, to scale this thing, you pretty much never really run just one process. You run a Zeek cluster. And so in Zeek, we cluster at the level of processes. There's threading in every process, but sort of for sake of understanding what Zeek does, it actually doesn't matter too much. And so if you're running Zeek as a cluster, the question is, of course, how do you get that cluster to communicate? And what we do there is events publish, subscribe. So we basically have these message buses between the processes over which you can exchange these events that I was just talking about. And this is probably stuff that is really familiar to many of you, but I thought I'd explain it real quick. So what is an event in Zeek? What does that look like? So it sort of looks like the notion of a function call, but only the inputs to the function, not the function itself. So an event has a name and it has arguments. So here, for example, is an event for whenever a connection gets established, and it has one argument. It's a connection that is a typed sort of data structure that's called C here. It doesn't really matter too much. And this is sort of a similar example to this for TLS, just to sort of show you that this can get sort of pretty rich. So several arguments here that all have different types and so forth. So that's what an event is like in Zeek. And so publish, subscribe works pretty much the same as it exists in many other systems. So you start from a topic. A topic is sort of like a message bus. Here, there's one hypothetically called Zeek cluster worker. Topics have sort of, structured names. How that really looks can sort of depend on the actual sort of message passing technology you're using. With the current go-to technology in Zeek, it's just sort of a hierarchical path. And then what happens is that consumers attach themselves to that topic. So let's say you have two of these worker processes here. They basically say, like, I want to receive the messages that are going onto this topic. So they're subscribing. And then over on the other side, you have another node that, let's say, publishes an event. In this case, let's just say it's called foo and has no arguments. And then after that event is published, basically the two workers get a copy each of that event to consume it. So publish and subscribe, really straightforward. So yeah, just sort of like wrapping this up a little bit. So you have these nodes, they sort of do different things in the system, and they use event, publish, and subscribe to communicate. And this is basically what a running Zeek cluster does. Okay. So let me show you a couple of ways, this is sort of the essence of the talk, in which you can integrate with this running system if you have other applications in your infrastructure. So the first, and like obviously the reason why I just went through all this event PubSub stuff, is you can do publish and subscribe also from other components. And the way we do this is that we expose a port from one of the nodes. Usually we use what's called the manager node, which is sort of the most high-level node that sort of centralizes state and so forth. And we use WebSockets for this. And so what you can do now, if you have another application that speaks WebSockets, is you can connect to it. And then we have a pretty sort of high-level protocol where you can basically express what are the topics you want to subscribe to, and then you can go off and start to send and receive messages. So after you've connected through this port and you've sort of set up this initial exchange, you're essentially part of this application, and you can now do PubSub in the system, just as if you were an actual quote-unquote, Zeek process. And the code at the bottom there is sort of at a very high level and very abstract, what it would look like in Zeek script to do that. So basically you say like, hey, I want to listen on a WebSocket, and then, if something in the system does this publish, if the application is subscribed, it gets it. If the application creates an event and a Zeek node is subscribed to it, it gets it. Pretty straightforward. Oftentimes you sort of have the inverse model. So instead of having an application that you want to talk into Zeek with, you have an existing application that has, a REST API or some such, or some HTTP API, and now you want to talk to it from inside Zeek, sort of as it's doing its traffic processing. And you can do that too, and the technology that we like for this is Zeek's JavaScript support. And that's basically just straight up JavaScript. So like, if you know JavaScript a little bit, then you know that there are sort of several ways in which you can do web requests. So this is just a sketch at the bottom, sort of, but this is then essentially not event I/O. It's really just standard HTTP I/O. So you reach out to the endpoint and you get answers back, and you can basically interpret them as such, and then maybe, translate them back into events or set up state or whatever you want to do with it. So this is sort of the reach out kind of model. This I wanted to mention because it's a really old school way to integrate with Zeek. This has been there since at least for a decade, I think more like 15 years probably. It's called the input framework, and another framework that builds on top of it called the Intel framework. Very traditional. It basically works on the assumption of you have files that contain pretty much arbitrary information. They can be formatted in sort of tab-separated files, JSON, CSV, sort of several things, and you can basically point Zeek at it, and then it will ingest that either once, or you can tell it to watch the file for appended content and so forth, and then basically sort of absorb that in real time. And what usually this leads to is some sort of form of logs again, maybe enriched with additional context that file provided. And then what some applications have been doing for a long time now is basically take some of these logs, read them, update the input file, and feed that information back into Zeek. So you basically get this sort of, let's say, file I/O based sort of, feedback loop. So if you don't want to run a separate service or sort of, set up additional infrastructure, this is a pretty straightforward way to do that. And there are many sites that have done this. This is newer. This is using our new storage framework for interacting with the outside. So the storage framework is just basically a flexible mechanism to access data stores that appeared in Zeek 8, which just came out a couple months ago. And the way it works is that you basically get a really straightforward, high-level get-put API for keys and values, where the backend chosen defines how the actual data store is implemented. So we ship with, SQLite, we ship with Redis, and it's really quite straightforward to implement others. And so you basically now have an interface to databases, if you will. And then you can use that database also as an interface to another application that also speaks to that database. And so now you basically have sort of a two-way path to communicate with centralized data. This one is technically sort of cheating a little bit because it's not an open-ended application, but it is an integration with Zeek, so I wanted to mention it. And it's our telemetry support. So telemetry just means that if you run a Zeek cluster pretty quickly, you will want to know, how is that thing doing? How is the CPU? How is memory use? Or more fine-grained things about, like what's the number of TCP connections versus UDP or others, and so forth. And we support that via Prometheus. This is probably also a pretty sort of well-known concept to many of you. But the way that works is kind of cool. And if you follow Zeek's development, then you may have noticed that we sort of iterated on that design a little bit. And so what we do now is we use something called service discovery in Prometheus, where the way it works is that Prometheus basically reaches out to this one port that we have that is just an HTTP endpoint, and you request a file called services.json, and that is just a straight-up indirection mechanism. So what services.json does is it basically lists in a little JSON blob all of the other endpoints you can talk to in the cluster, and then Prometheus goes out to all of these endpoints and scrapes metrics and scrolls them away so you can then use it for dashboarding and stuff. And this is sort of, there by default. If you're running a Z cluster, you can just check the available ports and you can go to town on them. Okay, so this is sort of conceptually how this works, and now I'm going to show you a handful of examples of how people have actually used this in practice. So all of these examples are real. Some of them are sort of in transition, so I'm going to talk about sort of the newer way in which they're going to work. And where I'm able to, I can point you at software, so because a lot of that stuff is open source, and sometimes if you're interested, I can at least point you at the right people to talk about it, because sometimes it's just sort of internal setups at various sites that use. Okay, so a first example is basically network entity mapping. So you basically want to keep a map of all of the things that are running around on your network. And so Zeek is really good at that kind of stuff because it basically picks up on any activity on the network via the conlog or some such. So any speaker on the network is pretty sort of naturally identified. So you can come up with a log that just sort of records this. And now the problem is that the network only tells you so much about what a particular speaker on the network actually means, what a particular, entity is. And so what you can then use to make that better is basically this example that I showed earlier, where an application now ingests that, provides that context. So you might have the knowledge that a certain network prefix is a certain department in your organization, or that it is on a certain Wi-Fi or some such. And then basically feed that back into Zeek. So it's that kind of, feedback loop example. And the site that I'm having in mind here is a university. They use that for, I think they have about 35,000 students. And they're, I think, still using that approach today, even though the way they're implementing it has sort of shifted. But for the longest time, they used actually the file-based approach for this that I showed earlier. Machine learning and anomaly detection. So this is something that we do a lot. So the use case there is that you basically are running Zeek, you're processing traffic, and you need some sort of information, some sort of decision that comes from some machine learning model, say to know if a particular DNS request is a DGA or, something like that. There are lots of cases. So you basically do that by running an ML model in a standalone server. And then this can go either way. In this case, we talk into Zeek, so we use the WebSocket approach, and then it's just event pops up again. And the way you can use events for this is that you basically model pairs of events as remote procedure calls. So this is, somewhat loose. Maybe if you looked at this earlier, you noticed that events don't really have sort of proper recipients. It just happens to be whoever is subscribed. So you're sort of abusing that model a little bit here, but you can add, request IDs or some such, and then basically track the round trips, and you have an RPC, a simplistic one, but one that works. And then Zeek basically subscribes to the response topic, you get your answers back, and then there's your classification, and Zeek can basically go on and incorporate that. context enrichment that is sort of related. A use case that often comes up is that you would like to have host-based context for your network flows. This is also really old. This has been around for a long time, although what kinds of context people want sort of depends a little bit on the site. So something that you can do there is you can ship something that we provide called Zeek agent, which is basically a host agent, very poor man's sort of EDR. No D, actually. Just sort of context. And that does exactly the same approach that I just sketched earlier. So this uses WebSockets to talk into Zeek and then basically feeds events into the system. And it can then do things like tell you, what was the user that created a connection, what was the application that created a connection, and so forth. And then the output for you is essentially a conlog that has additional columns that, includes that context. And this is pretty cool and pretty polished. This is a lot of time that Robin spent on this. And you can check that out in the slides. That link down there will take you to all of the details. File analysis, Yara. So this is kind of interesting because you could structure this in many ways, but so you can use Zeek's file extraction and then probably provide additional metadata about where the file came from, what you want to know about it, and so forth. So it's sort of like a job queue. And so one good way to build that is to basically use the storage framework and squirrel away the job tasks that you're sort of enqueuing there into a database, and then have a separate service that is hooked up to Yara to basically then sort of like grab the service requests, process them, and move on. So pretty straightforward, but basically the persistence of that job queue is pretty essential in this case, and that's something that the storage framework gives you pretty nicely. Access control lists and shunting. This is cool. I really like this one. I can tell you this is a use case that comes from Berkeley Lab over in California. And they've been doing this for a very long time. And so because their model is very open, so they're not like default deny, but basically block abusive sort of speakers into their network on the fly. And they use Zeek Zeek is one of the triggers for these blocks. And what they do there is basically do scan detection and similar things to identify abusive speakers, and then use infrastructure that is hooked up to, their switches and so forth to say, like, block this. I don't want to see that anymore. And this is, again, using the PubSub approach right now, although it should probably actually be using the JavaScript one because they already have a REST API that you can submit these queries to, but you can use either sort of. And so the way it works is that various things in their infrastructure can issue these blocks. Zeek is one of them, and basically for every request, it gets a reply back that says, like, yep, I've blocked this, that was already blocked, or information about the timing, and so forth. And you can do this similarly for shunting. This is kind of interesting. So in their case, the shunting approach, so basically the shunting here means that for things like elephant flows, so for very large flows on your network, where at some point in time you can make a decision that you no longer care about the packets in this flow, say for, control packets, so you still know how much, content got transferred, you no longer care. And they use a very similar model for issuing these shunts, although, there are many other technologies for this, but including host local ones via XDP and so forth. But for something that is sort of a little bit more distributed, you can also use this approach there. MISP needs no introduction here. Right? Cool. So the use case there is simply to integrate with a threat intel service. And so this is another one where we have code that you can try out. This was, I think, one of the first things we built using JavaScript. So what this does is quite straightforward. Conceptually, it simply reaches out to retrieve new indicators, doing attribute searches. Zeek then translates that into the concepts it has in its intel framework, sort of looks out for them. And every time there's a match, it basically goes back to the API in batches, I believe, and reports them as a sighting. And if you're curious about the JavaScript stuff, if you just poke at the code there, I think that gives you a pretty sort of, pretty quick impression of what that is like. Working with large data sets is another one. I sort of already sketched that earlier. So oftentimes you have a need to work with a really large data set, and you don't want to load that in bulk into memory, certainly not from multiple processes where you would be loading it redundantly. So a database is a really good answer, right? And so you can use the storage framework again. And what we like in particular is that you can use the external application to pre-populate such a database, or also then maintain it continuously once you're running live. And Zeek doesn't need to load anything. If it knows the structure of the database, it can just run queries because it knows what to look for and then get the answer back really fast, which is nice. So for large data sets, this is now our preferred way of doing that. Okay, and I don't know where I am on time. Good. Pretty cool. Just a couple more slides for the event PubSub stuff if you want to actually try this out. So if you have the choice, we would recommend that approach because it basically sort of integrates you the most with Zeek, and it's sort of conceptually closest to how we sort of view the whole thing working, which is just as a large distributed event-based system. So it shouldn't really matter where an event comes from or goes. Zeek is one of the producers of them, but it could be others, and then the whole thing is sort of quite homogeneous, which is nice. So the problem is you have to sort of think in terms of PubSub, which can be pretty unusual. For example, if you want to send something to a particular endpoint. And so this is just a couple of quick recommendations. There are a couple of modules that we provide for various languages that make that event PubSub really easy. I'm about to show you a couple. So if you have one in there for your language, then don't write it from scratch. You don't need to understand a whole lot that way. Basically just a high-level API to work with, and then that's the thing to use. And try to use, as I showed earlier, just a single WebSocket to talk into the cluster and do the rest via PubSub. It's sometimes tempting to basically open up a port everywhere and then have your infrastructure to, talk to all of these endpoints, but it's much cleaner if you just do that with only one and then basically spread the events from there. It's also much easier to understand than what happens if you want to monitor ports and stuff. So a couple of current implementations. We have one in Go that is written by Corelight. There is one in Python that is in a component called Zeek Client, which is sort of a command line client, but quite easy to reuse. There is the most exciting one, I think, that my colleague Benjamin is working on right now, that is combining Rust and Python, and that'll probably be the go-to solution going forward within a few weeks. And if you're interested in the sort of native code department, Zeek Agent is written in C++, so it has a bunch of this infrastructure if you are able to, externc it or something, but basically use it from a native, language. And this whole space is very much in flux right now because we're sort of messing with a bunch of the components in there. I think last year I actually already talked about ZeroMQ as a backend for the cluster. But so it means that we're basically touching a lot of this at the same time. And so some of the documentation you see somewhere is maybe no longer up to date and so forth. So we're hoping to make all of that much more straightforward in the very near future, but right now you might find this a little bumpy. And probably the most pressing advice I have is, if you know Zeek a little bit, then you know that sort of traditionally we have this in-house message passing software called Broker, so basically dating back to the days where you didn't have a lot of off-the-shelf sort of choices for this. Don't use that, because essentially all of the other things that we're offering is better than this sort of better in the sense of more lightweight, more minimal than this pretty heavyweight library where you always need to run, a native code library under the hood, even if you then just want to run Python bindings or some such. They work, it's used by many people, but we think it's a little bit too clunky, and it also has implications on PubSub that aren't so nice because you need to sort of understand the topology of who's connected to whom and so forth. So there are better solutions there already, and going forward, basically steer clear of that one. And most importantly, I think of all of those things, if you have questions about this, if you want to build an integration and you're not sure how to start, where to start, just come talk to us. We would love to talk to you because this is also interesting to us. Pretty much all of these applications are interesting. What did I show you? Maybe a half dozen earlier. They're established, but there is a ton more to build. And every time we learn of one, literally, we learn something. It's pretty interesting. So come talk to us. And that's all I have. So, I don't know how useful that was for you guys. It's probably only relevant if you're already running Zeek. If you're not running Zeek, then maybe this could convince you that, it's not the system that you run in isolation, but it's sort of a component of your security posture, of your security infrastructure. And here's a bunch of links that you can check out to get started in that case. So thank you. I'll give some questions.
Thanks a lot, Christian. Questions?
Oh, hey, there's water. Cool.
There is water. Sorry, you on the extreme right.
Only in the room, right?
Hi, thanks for the presentation.
Thank you.
I was wondering on the basically mirroring network, port mirroring or some other mechanism side. Is this also feasible to kind of just sample it and for like high bandwidth scenarios, so you don't have to send all the packages from every stream, or you need those?
Yeah, great question. So this is going right at the heart of tapping issues, which is one of the hardest problems in the space. So two answers maybe. So one challenge can be actually only getting one copy of all the traffic. That's probably not what you mean. But that can be an issue in practice where it basically, regardless of where you tap in your infrastructure, you're not able to get this one canonical instance of all traffic. So you start to see things duplicated. So that can be annoying. Sort of the opposite of sampling. You see too much of it, even though you already see everything. And then for sampling, it gets a little tricky because it depends on how much information you want to preserve. So if you just want to understand who is talking to whom and roughly at which volumes, you can use sampling in your tap solution directly, but you will lose a lot of signal in the data that Zeek gives you because it won't be able to parse to the traffic anymore because that information won't be there. It depends a little bit on the exact parser that we're using, whether you can recover after gaps. Sometimes you can, sometimes you can't. But if you brutally sample, only every fifth packet or so, that probably won't work. But then, you basically get sort of connection level information. That can be good enough, but you lose a lot of sort of information. Zeek does not per se give you sampling that would be a little below it. Okay, cool.
Thank you for the talk. My question is not about this talk.
Yeah, go for it.
It's about his question. Does Zeek do any deduplication, or do we have to?
Yeah, that is a good question that also always comes up. The short answer is no, not right now. But it depends on the traffic a little bit. So for TCP, for example, it doesn't necessarily get confused by duplicate traffic. It just wastes resources. Like you crank more cycles than you need to.
Thank you.
Yeah. I'd look at hardware vendors in your switches and stuff that give you that. Yeah. Although we're tempted to actually add it, even though it'll be horrible in brute force, but for many people it would still be sort of like a first step. Yeah.
Hello.
Hi.
So, two questions actually. If there is a rule of the thumb to when to switch to single node from cluster regarding traffic volume or bandwidth.
Mm-hmm.
And the second one is for the Intel framework, if using clusters improves the performance of the checks for large datasets.
I see. Okay. So let me see. So the first question was when you might get by with just running single node?
Yeah.
Right? Okay. So that is hard to answer in general, but essentially, as long as you're fine with just one process, like you don't take out CPU, you're totally fine. Ballpark, that is really hard, but I would say probably not more than a few hundred megabit, if that. A very common use for single node is to not actually do live processing, but just crank PCAPs, because then if you get by with that, there's also for PCAPs the sort of opposite idea of running a cluster, so you can speed that up. Sorry, it probably doesn't matter for you. But so basically just try. Like you could simply just, like if it's a very small network, you just try with one. If you see tons of packet loss, then you run a cluster. And I'm sorry, the second question was, right, if the Intel framework helps. with performance in the cluster. So I think that's also a little hard to answer, but essentially what happens is that there's one node in the cluster that distributes the Intel info out across the cluster, and then all of the matching is done locally in the workers that actually do the traffic processing. So in a way, it doesn't really matter, because it's the same amount of work that is done per node that does traffic analysis, as long as each node sort of sees roughly the same traffic. But maybe the best answer to say is like, just don't think about that, because the framework should take care of it for you. Okay? So or maybe the best answer is simply to say that it doesn't matter if you have one worker node or 100. The matching is always done locally, so it scales with the number of workers.
Okay, thanks.
Yeah, cool. Okay.
Anyone else? I think that's a no. Thank you, Christian.
Cool. Thank you, guys. Cool.